Hello students, welcome to the lecture series of JEE Corner. This is our lecture number 1 and in this lecture I am going to discuss some special problems of inverse trigonometric functions and these questions will help you to develop your knowledge about the chapter inverse trigonometric functions and so that you can it will be very helpful to the JEE and examination and some other engineering entrance examination also. So let me start the video. So this is our first question. If sine inverse x plus sine inverse y plus sine inverse z is equal to 3 pi by 2, and one special condition also given in the question that f1 is equal to 2 and a functional relation is also given here, f of x plus y is equal to fx into fy for all real values of x and y. And you are to prove you are to find this value of this expression. So let me start this solution. First of all, you see here that sine inverse x plus sine inverse y plus sine inverse z is equal to 3 pi by 2 is given, and we know, you just write we know that very simple, any sine inverse function, this is always from minus pi by 2 less than is equal to, it may be sine inverse of x, or it may be sine inverse of y, or it may be sine inverse of z also. And these values are always between minus pi by 2 and pi by 2. And it is obvious, but it is given in the question that sine inverse of x, since you write since sine inverse of x plus sine inverse of y plus sine inverse of z, this value is given as 3 pi by 2. So obviously from here we can conclude that sine inverse of x is equal to sine inverse of y is equal to sine inverse of z is equal to, obviously this is equal to pi by 2. So now you see here, we can conclude here that x is equal to y is equal to z is equal to, then sine of pi by 2 will give us 1 only. So x, y, z, all these three values are equal and it is equal to 1. Now come to the second condition given here. The second condition of the function is given f of 1, this is equal to 2. As well, a functional relation is given here, f of x plus y, this is equal to fx into fy. And let me replace x and y by 1, that means f of 1 plus 1, this is equal to, this is f1 into f1, so obviously this is f1 square. So finally we conclude that this f2, this is equal to, f1 has the value 2 given, so we write this is 2 square only. Then we can also find f3 is equal to, obviously this is nothing but f2 into, if see here, obviously you can write f of 2 plus 1 here, and that is equal to, by the functional relation, it is f2 into f1. And you see f2 has the value 2 square, so we can write 2 square here, and f1 is obviously 2 given in the question, so 2 cube means 8 is the value of f3, and we need these three values, f1, f2 and f3. And here we obtained f1 is already given in the question, f2 is equal to 4, you can write this is equal to 4 and this is equal to 8. So now you replace these values in the expression, therefore you write here, so therefore x to the power f1 plus y to the power f2 plus z to the power f3, then minus x plus y plus z whole terms divided by f1, not f1, x to the power f1, x to the power f1 then plus y to the power f1, then plus z to the power f1, y to the power f2, and z to the power f3. This is equal to, you see, x is 1 and f1 is equal to what? F1 is equal to 2. So 1 square mean this is 1, then plus y is 1 as well. This is y equal to 1 and to the power f2, f2 is equal to 4. So 1 to the power 4 is also 1. And in the similar way, this is also 1 minus 1 plus 1 plus 1 divided by 1 plus 1 plus 1. So ultimately, this is 3 minus 1 and that is equal to 2. And so this is the solution, and the option number 3 is correct. So this is the solution of the problem. Next, then you see the next question. If summation of r from 1 up to twice n sine inverse of xr is equal to n pi is given, then what about xr? So in this question also, you write this line again. So we know this minus pi by 2 less than or is equal to sine of xr is given here. So I am writing xr here is also less than is equal to pi by 2. And here r is going from what? R is going from 1 up to twice n. So r is going from 1 up to twice n as per the given question. And now you see, therefore, this expression, take this expression, it is summation of r from 1 up to twice n, then sine inverse of xr, and that is equal to n pi. This is given. This is equal to n pi. So that is implies, you see, r from 1 up to twice n, then it is n pi. So if we take the summation from r 1 up to say n, then we will have sine inverse of xr is equal to, obviously this is n pi by 2. Just replacing this n is half of twice n, and so writing n here, so it is half of n pi by 2. And you see, this will imply here the sum of n numbers of sine inverse x1 and sine inverse x2 plus sine inverse x3, that is n numbers are there, is equal to n pi by 2. So each of the sine inverse function, that is sine inverse of xr, individual term actually, sine inverse of xr, that is individual, either it may be sine inverse 1 or it may be sine inverse 2 or it may be sine inverse 3 or it may be sine inverse n. Each term should be equal to pi by 2, is not it? Because n term sum is equal to n pi by 2. So each term will be equal to simply pi by 2. And from here you see, we can conclude here that each of xr is equal to sine of pi by 2, and that is equal to 1 only. So xr is equal to 1, mean x1 is equal to 1, x2 is equal to 1, and so on. And therefore, we need the sum of this one. We need the sum of this one, that is summation of r from 1 up to twice n xr, and that is equal to actually x1 plus x2 plus so on up to x twice n. And each of this x1, x2, x3, all of the terms are equal to 1, that is 1 plus 1 plus so on up to 1, and there are 2n number of terms, and so the value is simply 2n. And so the option number B, this is the correct answer. So let me take the next question. If sine inverse this plus cos inverse this is equal to pi by 2, and where the condition on x is given from 0 to root 2 mod x, this given from 0 to root 2, then what about x? That is to find the solution of this actually. So we take this expression first. You see, I'm writing the solution. This is equal to, I'm not writing that, this is equal to sine inverse of, you see, sine inverse. What is the inner term? You observe the inner term, and that is a geometric progression, an infinite geometric progression. And common ratio is simply x by 2 here. So infinite geometric series sum is first term divided by 1 minus common ratio. First term is x here, so x by 1 minus common ratio is x by 2 only. And then plus second one cos inverse of, I have done a mistake here, is simple typing error. This should be 2 and this should be 4 and so on. So you see this is also a geometric series, and having first term x square and common ratio is x square by 2. So it will be first term, that is x square divided by 1 minus common ratio. Common ratio is what? It is x square by 2. And on the right hand side it is obviously given as pi by 2. Now it is just simplification here. Is implies sine inverse. You see this 2 is LCM, so we'll go to the numerator to make twice x, and it is 2 minus x only. Then plus cos inverse. Here also 2 is LCM, we'll go to the numerator. So in the numerator it will be 2x square divided by 2 minus x square only is equal to pi by 2. And so from here you see, you can write this is implies, you shift this term to the right hand side, that is cos inverse of 2x square divided by 2 minus x square is in the left hand side remaining, and on the right hand side it is pi by 2 minus this term, and which will give us cos inverse of 2x by 2 minus x. Is not it? It is actually pi by 2 minus this one, and by a formula of trigonometry, inverse trigonometry, it is simply is equal to cos inverse of 2x by 1 minus 2 minus x. We have this formula, sine inverse of x plus cos inverse of x is equal to pi by 2. Then cos inverse x is equal to pi by 2 minus sine inverse x, or sine inverse x is equal to pi by 2 minus cos inverse x. And we are using this formula here. And eliminate this cos inverse from both sides. So left hand side is 2x square divided by 2 minus x square, and on the right hand side it is simply 2x divided by 2 minus x. 2 is cancelled. As well, you see in the given condition here, you see here x is a non-zero term. Actually x is greater than 0, mean it is a non-zero term. Therefore x can also be cancelled from both sides. So we will have only x divided by 2 minus x square, and on the right hand side it is 1 by 2 minus x. Now a simple calculation, it is implies, I am writing here, it is implies, just take a cross product. It is 2x minus x square is equal to 2 minus x square. This negative x square cancelled from both sides, and so we will have x is equal to 1 only. And so the answer number, mean option number B, is the correct option for the question. So let me take the next question. This is our next question. Sine inverse of this plus sec inverse of this is equal to pi by 2. Then the value of this. So first of all, we try to find the value of x from here. From here, we try to find the value of x. So this implies, you see, sine inverse of, it is actually root over of what? It is actually root over of x plus 1 whole square, is not it? Then plus this is sec inverse of, again root over of x plus 1 whole square, and on the right hand side it is pi by 2 only. Then this will imply sine inverse of only x plus 1 is there, plus sec inverse of only x plus 1 will remain there, is equal to pi by 2. Now let me shift this term to the right hand side, is equal to, and this sec inverse can be written in this way, cos inverse of 1 by x plus 1. You can write this, and on the right hand side pi by 2 minus sine inverse x plus 1 will give us simply cos inverse of x plus 1. As done earlier in the previous question, this property is used pi by 2 minus sine inverse of x plus 1 will be equal to cos inverse of x plus 1. Now remove cos inverse from both sides. It is 1 by x plus 1, and on the right hand side is simply x plus 1. Now it will imply x plus 1 whole square is equal to 1. And this is implies x plus 1 will be is equal to plus minus 1. So from this one, we see that is implies x is equal to, by considering the positive sign, we will get 0, and which is not possible because x is not 0, it is given in the question. So it is not possible. Not possible. So we have the second option, mean x is equal to, by considering the negative sign, it will be minus 2 only. So minus 2. This is the acceptable solution for x. Now we have to find this value. So therefore 2 times of sec inverse x by 2 plus sine inverse of x by 2, this is equal to 2 times of sec inverse. X is minus 2, so my x by 2 means minus 1 only, and plus sine inverse of, this is also minus 1. And this is equal to 2 times of, now sec inverse minus 1 will be is equal to, you know this one, it is pi minus sec inverse 1 only, and this is minus pi by 2 only. So this is implies twice pi, and sec inverse 1 is 0 only, so minus pi by 2 is there, and which will give us 3 pi by 2 only. So the solution is 3 pi by 2 only, and this is the option 3 pi by 2, and that is the correct option. So let me take the next question. The set of the values of x satisfying the relations tan square sine inverse x is greater than 1. This one. So we start with this relation tan square. We write tan square sine inverse of x. This is greater than 1. And so we have a theory. You recall it. If you have x square greater than a square, then it will imply that x is less than minus a and x is greater than a. We know this one. And applying this theory here, it is 1 mean 1 square actually, and it will imply that 10 square of sine inverse 10 of sine inverse x, this is 10 of sine inverse x, this value is less than minus 1, and secondly 10 of sine inverse x, this is greater than 1, by using this theory. And so this is implies 10 function, inverse function is an increasing function, 10 function. So if you take this 10 function on the right hand side, it will be simply, sorry, before that you can write in this way also, it is less than minus 1 mean it will go to the negative infinity side. So we can write in this way, minus of infinity less than 10 of sine inverse of x, this is less than minus 1. And the second relation, x is 10 inverse of this is greater than 1, mean 1 will remain here, then 10 inverse of, not 10 inverse, it is 10 of sine inverse of x, this will go up to positive infinity. Then we already know that function 10 or 10 inverse, these are increasing function actually. So if you take this 10 on both sides as inverse function, then 10 inverse minus infinity will give us minus pi by 2. This is less than, we have now sine inverse x here, and this is less than 10 inverse of minus 1 will be equal to minus pi by 4. And so this one, 10 inverse of 1 will be is equal to simply pi by 4, and it is simply sine inverse of x, and less than 10 inverse infinity is only pi by 2. And this is implies, you see, If you take this sine function, sine inverse function is also an increasing function. So sine inverse can be taken on both sides. Here also sine inverse can be taken on both sides. So sine inverse will come here. It will be sine inverse of minus pi by 2 will give us simply minus of 1. Then x will be there. And sine inverse of minus pi by 4 is minus 1 upon root 2. And for this one, sine inverse of pi by 4 is only 1 upon root 2 less than x is there, and less than sine pi by 2 will be is equal to 1. So actually what is the solution now? You see, you try to see, understand this. This solution is actually now, you can see in the real line also. You can see in the real line. So this is the real line cell, and say this point is minus 1. This point is minus 1 upon root 2. Then this point is 1 by root 2, and this point is say 1. And as per the solution obtained here, it is from here up to here and from here up to here. And that is written in this way also. Both of these two combined can be written in this way. It is the interval from minus 1 up to 1. That means from here up to here. Then minus this closed interval of minus 1 by root 2 to 1 by root 2. So this is the interval where x belongs. Okay, so I think this option is in the question, minus 1 1 up to this one, minus 1 1 and minus 1 by root 2 up to plus 1 by root 2. You see here, this is the solution. And so our option number 3, option number C, this is the correct option we obtained here. Okay, so let me take another question. Now this is our question. If u is equal to cot inverse of root over cos theta minus tan inverse of root over cos theta, then what is about sine u? So first of all, we write this expression here. From this expression, we start with this expression is implies u is remaining same in the left hand side is equal to, we can write this cot inverse as pi by 2 minus tan inverse of root over cos theta. Simple. Then minus tan inverse of root over cos theta is already there. Okay, so finally we get here u is equal to, it is simply pi by 2 is already here, then minus 2 times of tan inverse root over cos theta. So I think you understood this is implies. Now we are asked to find the value of sine u. So I am taking sine on both sides. That means sine u is equal to, on the right hand side it is sine of this total term, mean pi by 2 minus 2 times of tan inverse of root over cos theta. Okay, so this is implies, you see, sine u remaining same is equal to the sine of pi by 2 minus something, mean pi by 2 minus theta format, and it will be is equal to cos of this expression, mean 2 times of tan inverse root over of cos theta. Okay, so this is implies sine u, this is remaining same in the left hand side, is equal to cos is also remaining same here. Okay. And this 2 tan inverse x format, and in terms of cos inverse it can be written as cos inverse of, you see, cos inverse of this can be written as cos inverse of 1 minus x square by 1 plus x square format. So we write 1 minus x square, means this total term square, root over will be eliminated, so it is simply cos theta divided by 1 plus x square, mean cos theta only. So this is the expression we have. Now cos and cos inverse will eliminate. Therefore, it is sine of u is equal to, this is gone, this 1 minus cos theta here divided by 1 plus cos theta here. And so this is implies sine u is remaining same in the left hand side is equal to 1 minus cos theta can be written as 2 sine square theta by 2 divided by 2 cos square theta by 2. So finally we see here that sine of u is equal to 2 and 2 cancel, sine square by cos square is tan square theta by 2. And I think I got the answer here. You see the option tan square theta by 2 is in the B, option number B. So B number option is the correct option. And then we take another question. This is our question now. If theta is equal to tan inverse of 2 tan square theta minus tan inverse of 1/3 of tan theta, then which of these following options or option is correct? So we start with the given expression here. From this expression, I am checking tan on both sides actually. It is simply tan theta, it is simply, you can write like this. It implies theta is equal to, combining these two tan inverse formula, it is tan inverse of this minus this. So we write 2 tan square theta, then minus 1/3 of tan theta whole terms divided by 1 plus 2 tan square theta into 1/3 of tan theta. Very simple. Tan inverse of x minus y formula, tan inverse f by x minus tan inverse of y is equal to tan inverse of x minus y divided by 1 plus xy formula. So then it is implies this tan inverse can be taken on the left hand side as tan theta is equal to, now here by taking LCM 3, here also LCM 3. So numerator is simply 6 tan square theta minus tan theta only, whole terms divided by this 3 will come here. So 3 plus 2 tan cube theta. So we write 2 tan cube theta. And from here you see by taking the, so you can take Cartesian product, but it will be simple if you take this left right hand side terms to the left by taking tan theta common also. You see tan theta is also common. So from this term 1 will remain, then minus from this term 10 is already taken common. So in the numerator we will have only 6 tan theta minus 1 whole terms divided by 3 plus 2 tan cube theta is not it. And on the right hand side it will be equal to 0. So you see here this implies these two factors product equal to 0 mean individual factor mean this tan theta maybe is equal to 0, or second option is 1 minus 6 tan theta minus 1 divided by 3 plus 2 tan cube theta. This is equal to 0. And from here tan theta is equal to 0 is obtained here. And from this one, take LCM here, it is 3 plus 2 times of tan cube theta minus 6 tan theta minus or minus plus then 1 on the right hand side, it is equal to 0. Just taking LCM and taking cross product. And we write this in this way, 2 tan cube theta is already here, then minus 6 tan theta is there, 3 plus 1 is 4, so this is equal to 0. Now we can divide by 2 here, so we will have only tan cube theta minus 3 times of tan theta and plus 2 is equal to 0. And from here you see how we have to solve this one. one of the solution is already obtained, tan theta equal to 0. And from here you see, if we apply tan theta is equal to 1, say, if we apply here tan theta is equal to 1, then it will imply that this is 1 minus 3 plus 2 is 0. So since tan theta is equal to 1 is satisfying this relation, that means tan theta minus 1 is a factor of this relation. So that can be written in this way. You can write tan square theta into tan theta minus 1. So this tan cube is already adjusted. It is minus tan square, so we have to cancel tan square. So plus tan theta into tan theta minus 1 will be there. So this positive tan is negative tan square and positive tan square is cancelled, then it is minus tan theta. But it should be minus 3 tan theta. So we can write in this way, minus 2 times of tan theta minus 1 is equal to 0. Is equal to 0. You can write in this way, is equal to 0. The last one is already adjusted. Now we can take tan theta common. Tan theta minus 1 is common. So this is implies we can take tan theta minus 1. This term is common. So within bracket, this is tan square theta, then plus this is tan theta, and then minus 2 is already there, is equal to 0. Then which will imply it is tan theta minus 1 is already here, and here again we can take factorization here, and it can be done in this way: tan square theta plus 2 tan theta, you see here 2 tan theta, then minus tan theta, and minus 2 is already here, equal to 0. And so this is implies this tan theta minus 1 is already here, and from these two terms we can take common tan theta only. So it will have only tan theta plus 2, and minus is taken common here. It will be tan theta plus 2 is equal to 0. Then you see it is tan theta plus 2 is again common, and tan theta minus 1 will again be there. So we will have tan theta minus 1 whole square will be there, and then it is tan theta plus 2 is equal to 0. And so from this relation we can say that this factor is 0, that is tan theta minus 1 whole square equal to 0 means this is also equal to 0. Or from here tan theta plus 2 is equal to 0, and it will imply that tan theta equal to 1, this is one of the solution, and from here tan theta is equal to minus 2, this is another solution. So we got three solutions: tan theta is equal to 1, tan theta is equal to minus 2, as well tan theta is equal to 0 is already obtained in this equation. So 0, 1 and minus 2 are the solutions, and you see in the option number B this is correct, 1 this is also correct, and minus 2 this is also correct. Okay, so let me take another question here. This is our next question. The number of positive integral solution of the equation tan inverse of x plus cos inverse of y by 1 minus y square is equal to sin inverse of 3 by root over 10. So let me express all of this cos inverse and sin inverse in terms of tan inverse. So to do that, you see our tan inverse x function is remaining same here, tan inverse x, plus if we write this cos inverse in terms of tan inverse, you see we can write this is root over of 1 minus this term square is y by y square by 1 plus y square and whole terms divided by this term itself, mean y by root over 1 plus y square. This is in terms of tan inverse is equal to, again, sine inverse function. So if we write in terms of tan inverse, it will be this term by, that is 3 by root over 10 whole terms divided by root over of 1 minus this term square. It is actually 9 by 10 on the right hand side. And here I am using this relation, actually cos inverse x is equal to tan inverse of root over 1 minus x square divided by x. And for this relation, sine inverse of x is equal to tan inverse of this x by root over 1 minus x square. These two relations are using here. You see here, these two relations are using here. So this is implies, you see, tan inverse x is remaining same, plus this tan inverse is already here. And what about this? After taking LCM, root over 1 plus y square, root over 1 plus y square will get cancelled. So in the numerator, it is root of 1 plus y square minus y square is 1 in the numerator only. 1 in the numerator, and denominator is y only. So 1 by y is equal to, here root over 10 cancel, 3 by 10 minus 9 mean 1. 3 by 1 is only 3. So we can write tan inverse of 3 only. Okay, so proceed. Okay, so from here you see, this is implies tan inverse of this term is here remaining same. Tan inverse of 1 by y is remaining same, and on the right side you can take tan inverse of 3 minus tan inverse of x. Tan inverse of x. This term is shifted to the right, and so this is implies tan inverse of 1 by y is remaining same here is equal to, combine these two, is simply tan inverse of 3 minus x divided by 1 plus 3x only. So eliminating tan inverse from both sides, we will have only 1 by y. This is equal to 3 minus x divided by 1 plus 3x. So what about y? So y is equal to simply 1 plus 3x divided by 3 minus x. Now we are asked to find the positive integral solution. Positive integral solution, the values of x and values of y. This should take 1, 2, 3, 4, etc. And this should also take 1, 2, 3, 4, etc. Positive integral solution. So the question was, how many positive integral solution of this equation will have? So you verify for x is equal to 1 here. You will see, if you take x is equal to 1, say I am taking x is equal to 1, then what about y? Y is equal to, you see here, 1 plus 3 is 4 by 2 is equal to 2. Y is equal to 2. It is obviously acceptable. Then if you take x is equal to, say, 2, then 1 plus 6 is 7 by 3 minus 2 is 1. 7 by 1 is 7. So it is also acceptable. Y is 7. But after this, if you take x is equal to 3, then it will be 1 plus 9 is 10, but 3 minus 3 is undefined. So we cannot take 3. Then similarly, 4 cannot be taken, because in that case, 1 plus 12 is 13 by 3 minus 4 is negative. As well, this is a negative result, and y cannot take negative value. And after that, if you take x is equal to 4, 5, 6, 7, in each case, the value of y will come as a negative integer, and that is not acceptable for the question. So therefore, only these two solutions we will have. That is, first set of solution is 1, 2 integral solution, and the second set of solution is 2, 7. So we will get only two solutions, integral solutions of the given equation. And so we will have the option number, you see the option number 2 mean B. Option B, this is the correct option. Okay, so after this, you see the next question. The mapping fx is equal to this is our function. A function is given here, fx is equal to ax plus b, and where a is greater than 0. A is greater than 0, and it is a map. Map means it is a function. That means f, this is a function from what to what? It is from the closed interval -1, 1 onto the set of 0 to this function, and it is given that the function is an onto function. As well, it is given that a is greater than 0. So a greater than 0 means it is a straight line type function, mean y is equal to ax plus b, mx plus c type function, mean it is a straight line actually. So straight line mean, and having a greater than 0 mean positive slope. So it is an increasing function as like this. It is like this. It is an increasing function. And an increasing function is onto. That means the left point of the domain mean -1, that is f of -1 will be equal to this left point of the function mean 0, and f1 will be equal to this right point of the function 2, because the function is on 2, that therefore the range of the function is 0 to 2 will be equal to codomain, and as well there will be no points after 2 and before 0. As well the function is an increasing function, therefore the left point will give the left value of the function, and right point will give the right value of the function. So f minus 1 is equal to 0 and f1 is equal to 2, and this will imply we find the value of fx first actually. So fx will be equal to this, f is -1, so it will be minus a plus b equal to 0, and for this relation f1 is equal to this a plus b only, a plus b, this is equal to 2. But from this relation we see a equal to b, mean we can write twice of a is equal to 2, and so a will be equal to 1 only. And if a is 1, therefore b is also is equal to 1. So what is our function now? So therefore our fx function is only x plus 1. Is that clear? Fx is function x plus 1. Now come to the next part of the question. We will have cot 7, cot inverse 7, cot inverse 8, and cot inverse 18. So we write here now cot of cot inverse 7 plus cot inverse 8 plus cot inverse, sorry, not cos, it is cot inverse 18. Now to try to find the value of this is equal to, cot is already here. All of them can be, this can be written in terms of tan inverse only. So we can write this is tan inverse of 1 by 7 plus this is tan inverse of 1 by 8, and plus this is tan inverse of 1 by 18 only. So this is equal to cot function is remaining same, and then combining these two by formula, it is tan inverse of, what is this, 1 by 7 plus 1 by 8 whole terms divided by 1 minus 1 by 7 into 1 by 8, then plus tan inverse of 1 by 18 is already here, this, and so this is equal to cot function is remaining same, then it is tan inverse of, what is this, you see this is 8 plus 7 is 15 in the numerator, divided by LCM is cancelled, 56 minus 1 is 55, then plus tan inverse of 1 by 18 only. Now you see we can take a divide in the numerator and denominator. It is equal to cot of 10 inverse of divide by 5 here. So it is 3 over 11, then plus 10 inverse of 1 by 18. So now again combine that two. So cot of 10 inverse 3 by 11 plus 1 by 18 divided by 1 minus 3 by 11 into 1 by 18. Very simple. And so this is equal to cot of 10 inverse. It is 54 plus 11 divided by 198. This is 198 minus 3 after taking LCM. This is 198 minus 3, and 11 into 18 will cancel out. Is equal to cot of, you see here, we will have 10 inverse of 54 plus 11 will be is equal to 65 divided by 195. So it will get 3 times actually. I am writing here is equal to cot of 10 inverse of 1 over 3. And so this is cot of 10 inverse can be written as cot inverse of 3 again. So this expression is equal to 3. Then in the question it was given that whether it is f1 or f2 or f3, this is the question you see. This one, f2, f3. What was our fx? Fx is equal to x plus 1. So x plus 1, we obtained the value of this expression as 3. We obtained the value of this is as 3. We got it 3, and fx is equal to this. So obviously f2 will be equal to 2 plus 1, and that is equal to 3. That is equal to 3. So option number B is the correct option. Option number B is the correct option. Not option number B, sorry. It will be option number A. Option number A is the correct option. So after this, you see the last question of this class. This is our question. 10 inverse x whole square plus cot inverse x whole square equal to 5 pi square by 8. Then the value of x is. So in this question also you see, you start with the left hand with the equation given. So we take the equation first. Okay, so you see the solution. 10 inverse x whole square, writing the equation. It is 10 inverse of x. This is whole square, then plus cot inverse of x. This is whole square, then this is equal to 5 pi square by 8. Now try to solve. Then 10 inverse of x whole square is remaining same. Then plus this cot inverse can be written as pi by 2 minus 10 inverse of x whole square is equal to 5 pi square by 8. And this is implies, complete this whole square. It is 10 inverse x remaining same. 10 inverse x whole square remaining same. Then plus it will be pi square by 4. So obviously then minus 2 into pi by 2 into this, and will be is equal to pi 10 inverse x only. Pi 10 inverse x. Then plus this term square is 10 inverse of x whole square, and on the right hand side 5 pi square by 8 in the right hand side. So this is implies this 10 inverse x whole square, this 10 inverse x whole square will make it 2 times of tan inverse x whole square, then minus pi tan inverse x, and this pi square by 4, and it is 5 pi square by 8. So if you take 2 pi square, so it will be minus 3 pi square by 8 is equal to 0. Is not it? Just multiply 2 by 2 in the numerator and denominator. So it is 2 pi square by 8, and here 5 pi square by 8. So will be 3 pi square by 8 shifted to the left. It is minus 3 pi square by 8. Now we can find the value of tan inverse x from here. It is a quadratic equation in tan inverse x. It is a standard quadratic equation in tan inverse x. So by using the formula of the solution of a quadratic equation, so therefore you can write like this: tan inverse of x is equal to minus b mean minus pi, minus of minus pi, it is simply pi plus or minus root over b square. B square mean minus pi square, it is simply pi square, minus 4 into a into c, that is 4 into a is 2 into c is this one, negative this one, so it will be positive, then 3 pi square by 8, and whole terms divided by twice a mean 2 only, this a. And so this is implies tan inverse of x will be is equal to, this pi is already here, plus or minus root over, you see here pi square and 8 cancel, plus 3 pi square only, and whole terms divided by 4. And this is implies tan inverse x is equal to, this is pi plus minus 4 pi square. 4 pi square root over mean it is simply 2 pi by 4. Now considering the positive sign and the negative sign, this is implies, so one of the solution is tan inverse of x is equal to, if we consider the negative sign, then it is pi minus 2 pi is minus pi by 4 is one of the solution, and the second solution is positive sign considering position 3 pi by 4, it is 3 pi by 4. But you see, but the range of tan inverse x function, this tan inverse x function is always in between what? Minus pi by 2 tan inverse x up to pi by 2. So this solution is not valid for this equation. Only solution is, therefore the only solution is tan inverse x is equal to pi by 4. And what was our question? Our question, sorry, not pi by 4, minus pi by 4. Our question was what is x? So it will imply x is equal to minus 1 only. So that is the solution. So option number what? You see the option number minus 1, B. Option number B is the correct answer. So option number B is the correct answer. So today we complete this class here. So in the next class we will do some more problems for other chapter also. So till then, thank you very much.